Hey YouTubers! So I've been wanting to make my own sampler. That seems kinda dumb since I already own a pretty good sampler, an EMU E6400 Ultra. But, you know, I like to make things. But it's not just making things being the reason that I want to make a sampler. You see, hardware samplers like the EMU E6400 and pretty much every software sampler alive as well, in order to pitch samples to different pitches, they will use a method called resampling. And resampling is literally like re-recording the sample at a different sample rate and then reading it back in at the project's sample rate. This can be done well or it can be done poorly, and it can introduce a lot of noise and artifacts in the signal if it's not done well. Of course, modern resampling algorithms are actually pretty darn good. But did you know that there is actually another way to do it? You see, back in the 70s and 80s, there were these things called Fairlights. And they had what was called an R2R ladder converter on the output. Now, an R2R ladder filter just takes your digital pins in and you get an analog voltage out, and that's all that happens. It can play back at any sample rate, and whenever you put a new sample on it, bang, you just get your new voltage. And this allows you to change the pitch of samples by doing nothing more than just changing the rate at which you're sending the samples out. So in that way, it actually works just like a tape recorder. So it's been my dream to make a sampler with a modern version of that idea. The problem is R2R DACs really don't exist for anything beyond 16 bits. And even at 16 bits, they're very expensive. You see, R2R ladders have a precision problem, that the more bits you try to convert, the more precise the resistors have to be made, and it gets to the point where if you're doing 16-bit and 24-bit conversions with these resistor ladders, that the resistors have to be at 0.00008 and 9% tolerance. It is absolutely ridiculous, and the lengths you have to go to manufacture chips like this is insane, and it makes these converters very expensive. In fact, the last company to even make 24-bit R2R ladders, they have pulled the product and they're not making it anymore. So now the highest resolution you can get is 16 bits. But 12-bit R2R ladders are actually pretty readily available, and it gave me an interesting and kind of evil idea. I am now wondering if I could do two 12-bit R2R DACs in parallel, have the most significant bits going to one, the least significant bits going to another, and then I would scale the outputs appropriately, which would mean dividing the voltage coming off of the least significant bits by 4096, and then mixing them back together. Now, if you're wondering, how are you going to hear a difference in 1/4096th of a voltage level? Well, that's actually a very good question. And in fact, there has been a lot of argument in audio circles over just how much resolution is really required. Apparently, some double-blind tests have been done that show that humans can hear to about 18 to 20 bits of resolution at the very best. Which means for most of us, 16 bits is just fine. And in fact, for a lot of us, 12 bits would probably be just fine. So what's all the brouhaha about 24-bit audio these days? Well, where 24 bits of audio really buys you something is at the input side rather than the output side. Because having all that extra headroom means that you can bring in the average level of your signal kind of low and you're not worried about losing resolution. So you have all that room for peaks to happen without getting any clipping. If you're recording at 16-bit, you run into the issue of wanting to record as hot as possible, which increases your risk of clipping. And since I already have other devices I'm using for recording and they all work at 24-bit, maybe I really only need 16 bits of output for this sampler to work really well. And like I said, there are chips available that are 16-bit R2R ladders that can operate at very high sample rates and, from the looks of it, at any arbitrary sample rate. So I could probably make a modern version of this kind of sampler actually work. Let me know what you think, YouTube. Leave your comments down below. And as always, thanks for watching, and good night.